So let's get started with another one. In this one we will try to derive the value of gamma 1 by 2. So in the previous one I have derived the value of gamma 1, and now I will try to derive the value of gamma 1 by 2. So what is the value of, we will now try to derive that gamma 1 by 2. So what will be the value of gamma 1 by 2? Now we know that gamma n is equals to integration 0 to infinite, and e to the power minus x, e to the power minus x, and then here it is the x to the power n minus 1, and there must be a dx term here. So it is the formula for gamma n, 0 to infinity e to the power x, x to the power n minus 1 dx. Now we will look for the gamma 1 by 2. So we will replace the value of n with 1 by 2 and see. Let's see what happens if we replace that value. Now let put n equals to 1 by 2. So here from that equation, from this equation, we can say that if we put gamma 1 by 2 in place of n, we have put 1 by 2 here, and 1 by 2, gamma 1 by 2 equals to 0 to infinite e to the power minus x as usual, and x to the power 1 by 2 minus 1 and dx. And if we do the integration 0 to infinite e to the power minus x and x to the power 1 by 2 minus 1 minus 1 by 2 dx. Okay, and now we have to do some substitution to do this integration. To do this integration we have to do some substitution. So let's do it here. Here let's take, what can we take? Let's take x to the power 1 by 2 equals to n. X to the power 1 by 2 equals to n. Let's substitute x to the power 1 by 2 with n. From here we can write it as gamma 1 by 2 equals to, and one more thing, it is x to the power half equals to n, so we can write it as x equals to n square, and this implies that d of x equals to 2n dn if we integrate both these sides dx, and here it is 2 which comes fourth, and n to the power 2 minus 1 1 n and dn. So now we will replace the value of dx with this one, and replace the value of x to the power 1 by 2. Here it is minus 1 by 2, so here it is x to the power minus 1 by 2, but here we have n equals to x to the power 1 by 2. So let's see how to replace all the terms. So here will be gamma 1 by 2 equals to that. So we can say gamma 1 by 2 equals to the entry. And one more thing here to note out, here it is x equals to n square, and now if x equals to, let's say x equals to 0, that implies also n equals to 0. If x equals to 0, then n equals to also 0, and if x equals to infinite, then n is also equals to infinite. From where you can say that, from if we put the value of x 0 here, you will simply get n equals to 0. And also if you put the value of x equals to infinite here in this one, x equals to infinite, then you will simply get n equals to infinite also. And now it's time to replace all the values. So it's another portion. Now integration 0 to infinity e to the power minus x to the power minus 1 by 2 dx, which is equals to e to the power minus x is equals to integration 0 to infinite, and minus x, instead of minus x we can put n square here, e to the power minus n square, and in place of x to the power minus 1 by 2 we can put simply x, in place of x we can put n square whole to the power minus 1 by 2, and in place of dx, here it is the value of dx, which is equals to 2 into n into dn. So simply replace the value of dx with this one, dx equals to 2 into n into dn. So after replacing that value of dx with 2 into n into dn, what we get? We get here 2 into n dn. And now it's time to integrate it. Oh, it's time to integrate it. Now let's integrate. Now 0 to infinite. See here it was the limit 0 from infinite, and we have replaced x, equals to n square, and what we get? We get these terms. We have also replaced the dx with that 2n dn, and there was in limit 0 to infinite. And I have seen that if we put x equals to x equals to 0, then n equals to also 0. So the limit is same, 0 to infinite. As if we put x equals to 0, then we see that n equals to also 0, and if x equals to infinite, then that implies n is also equals to infinite. So the limit of the integration is same, and we are, let's go ahead and see what happens. E to the power minus n square, and this after calculating becomes n to the power minus 1 2 into n into dn, and here it is n to the power minus 1, and here it is n, so that will go cancel out, and we have left with 0 to infinite. We have taken out 2 out of the integration, and it is a constant term 2, a value, and in the integration we have n square. For the ease of understanding, let's break this down as n minus 1 plus 1. Here it is n, and there is nothing, means there it is plus 1. Here it is plus 1 here, so we are writing just simply n here. And after multiplying n to the power minus 1 with n to the power plus 1, we get n to the power minus 1 plus 1, and here it is the dn term. So it's equals to 2 in 0 to infinite e to the power minus n square dn. Now there comes the interesting part. This is the most interesting part here, this one. Here we have integration 0 from infinite, and in the integration we have e to the power minus n square dn. So if you remember, it has a certain value. Integration of 0 to infinite e to the power minus x square dx equals to root over pi by 2. And there is a way to calculate this one. I will discuss that in another video. Now for simplicity, we are just replacing the value of this integration with root over pi by 2, because here it is also the same, e to the power minus n square into dn, same structure. Just instead of x we have here n. We have here integration of 0 to infinite e to the power minus n square dn, and it is the same structure where the value of integration is root over pi by 2. So just replace the value of this integration, 2 into root over pi by 2, and this integration becomes root over pi. So the value, so finally we get the value of gamma 1 by 2, which is equals to root over pi. So that's it all for the proof, and I think I have done it with correctly. Let's see once more again what we have done from the first. First we have to derive the value of gamma 1 by 2, and we know that the gamma n equals to integration e to the power minus x to the power n minus 1 dx, and the limit of integration is from 0 to infinite. Now let put n equals to 1 by 2, as we have to derive the value of gamma 1 by 2. Then if we put the value of gamma 1 by 2, if we put the value n equals to 1 by 2, then we get e to the power minus x and multiply by x to the power 1 by 2 minus 1 dx. From there, after calculating that, we get e to the power minus x into x to the power minus 1 by 2 dx. Then we have replaced the value of x with n square, and if x equal to n square, then we get dx equals to 2 into n into dn. And one more thing to notice, that if x equals to 0, then we have n equals to also 0, and if x equals to infinite, then we also have n equals to infinite. So the limit will be same, the integration limit of the integration will be same, 0 to infinite. Now after substituting x with n, here it is the n square, after substituting the value of the x with n square, we get this. The integration is same with limit 0 to infinite, and here we have e to the power minus n square, because here it is x up, and we substitute the value of x with n square, and here it is x, we put n square and whole to the power minus 1 by 2, minus 1 by 2, as it was x to the power minus 1 by 2, we have put n square whole to the power minus 1 by 2, and we have replaced the value of dx with 2 into n into dn. 2, because we have seen here dx equals to 2 into n into dn. And now moving further, we have calculated that here it is n to the power minus 1, and here it is n, means here it is only n, so means that it has a power of plus 1. So after calculating that, I mean multiplying n to the power minus 1 with n, we get minus 1 plus 1 into the power 0, which is 1, and in the integration we have 0 to infinity to the power minus n squared dn, and it has a certain value of root over pi by 2. And after putting the value of this integration, we get 2 into root over pi by 2 root over pi by 2, and 2 gets cancelled out, and we have the result root over pi. So the value of the gamma 1 by 2 is root over pi.